All right, we're going to talk about the precise definition of a limit. So let f of x be defined on an open interval about c, except possibly at c itself. We say that the limit of f of x as x approaches c is the number L, and write the limit of f of x as x goes to c equals L. If for every number epsilon greater than 0, there exists a corresponding number delta greater than 0, such that for all x, these are true statements. 0 is less than the absolute value of x minus c, which is less than delta, and the absolute value of f of x minus L is less than epsilon. Okay? So this is the formal definition. So if we want to show that the limit of 5x minus 3 as x approaches 1 equals 2, for instance, because we plug 1 in there, 5 times 1 is 5 minus 3 is 2. If we want to show that, what we're going to do is we're going to prove it using this definition. Okay? So here our c is 1 because that's where we're going towards. Our limit is 2. So we want to get to this. We want to have 0 is less than the absolute value of x minus 1 is less than delta. Okay? And so what we're going to do is we're going to kind of solve this and move it from f of x minus L is less than epsilon, and we're going to work this back to this statement here. Okay? So when we do that, we're going to come here and we're going to go 5x minus 5 is less than epsilon. So here we just put in our f of x, our actual equation for f of x. We put minus our limit, and now we're going to just simplify. Okay? Okay? So notice this is 5x minus 5. So I can factor out a positive 5 here. X minus 1 is less than epsilon. Now I can divide by 5. And I get the absolute value of x minus 1 is less than epsilon over 5. And that's going to show me my item, what delta is going to be. Okay? So this is going to equal delta. Okay? So now we're going to look at kind of our next piece with using this formal definition of a limit here. Okay? So the limit of the square root of x minus 1 as x approaches 5 is 2. We want to find a delta greater than 0 for an epsilon that's equal to 1. So we're actually picking a very specific value for epsilon. Epsilon is going to be 1. Okay? So we're going to plug this back into that x minus c. So here I have 0 is less than the absolute value of x minus 5, because that's my c, is less than delta. And we're actually looking for this delta. We're trying to find that delta. So we go back to our formal definition. We have f of x minus our limit is less than epsilon. Well, in this case, epsilon's 1. Our limit is 2, and our f of x is the square root of x minus 1. Now, to work this out, what we're going to have to do is we're going to have to get rid of these absolute values. Okay? So to do that, that means that I'm going to go from -1 to +1. Okay? Because I got to be able to solve inside of here. So I'm going to add my 2 to both sides, which is going to give me 1 is less than the square root of x minus 1, which is less than 3. And then I got to get rid of the square root. So I'm going to square it. So 1 squared is 1. Is less than x minus 1, which is less than 3 squared, or 9. And now I'm going to add my 1 over. So I end up with all 3 pieces. So I end up with 2 is less than x is less than 10. Well, if you remember, 5 is our c value, and it is actually nearer to one of the endpoints here. So these are our endpoints here, right? So 2 is less than 5 is less than 10. Well, 2 is closer to, or 5 is closer to 2, and in fact, it's 3 units away. So we're going to use that, and we're going to take delta to be 3. Because if we take delta to be 3, we know we're inside this 10 also. So x is less than absolute value of x minus 5 is less than 3. for all the absolute value of the square root of x minus 1 minus 2 is less than 1. So that's kind of working with our formal definition there. I know that this kind of is confusing, but most of it is trying to think of it in terms of algebra. You're trying to work back to getting this here, so that way you can kind of show what delta is going to be. So you're really trying to work back to the absolute value of x minus c, and then compare that to delta. If they give you an epsilon, they're going to work back. So this one, if I said epsilon was 1, now I know delta is 1/5. Okay, and that's what that formal definition is trying to get. As we get closer and closer, our epsilon's getting smaller and smaller, our delta's going to get smaller and smaller. So that's the precise definition of a limit.